Can you tell me what is the semiconductor industry state in India? Is it all being manufactured outside India, or what is the manufacturing here, what is the design here, and all of
Sure. Today, we're a net importer of electronics. It's a fact. We have a fab in Mohali, SCL fab. And if you take the entire semiconductor value chain, you have the chip design, and that's broken out into front end and back end. You have the manufacturing, which is again broken out into front end and back end. Then it goes to the systems. Now, if you take a look at this entire value chain, after the success of IT and the voice-enabled transcription services, we migrated to software services, which in turn led to basic simulation services for design verification of a chip. That's the front-end design. That blossomed and did very well over the last 2 decades. Pioneers like Texas Instruments set up shop here after HP, and then it just blossomed from there, from front-end design to even back-end design to the entire SoC in India. Today, we can proudly say that India represents around 20 to 25% of the global semiconductor chip design market space in the world. Number one is by far the USA still. More and more advanced chips. In fact, the most advanced chips are done in India by the global captive centers. We are working on cutting edge designs. Indian companies in the front end design space are not on the product domain, but more on the services domain. Then on the manufacturing side, if you were to break it out into front end and back end, front end being the wafer fab, as I mentioned, we have one fab, and we have about maybe, I would say, 7 or 8 R&D fabs doing R&D in the various educational institutions. There's 3 types of major front-end fabs, and India is focusing on display, CMOS, as well as compound semiconductors. The digital is what we see in our consumer devices and most of the computing, and compound is more on the power electronics and EVs, and then display, of course, is for the displays. We don't have a display fab, we don't have a compound semiconductor fab, but we have one digital fab at 180 nanometers. Tata has recently announced their plans to do a 91,000 crore silicon CMOS fab in Gujarat at 28 nanometers. There's talks of SCL upgrading to 28 nanometers. And 28, by the way, is nothing to be ashamed about. It's a very stable technology. It has good economics for Indian market. And we can produce the volumes we require at 28. And the 4 nanometers, the 3 nanometers, which are the so-called most cutting edge, it'll take time for India to reach that level, probably a decade. But on the back-end manufacturing, India is very strong. And when I talk about back-end, that can further be divided into the packaging and then to the EMS. India has already established itself as a global player on the EMS market. And when we talk about EMS or electronic manufacturing services, we're talking about these kits, knockdown kits. We import the kits and then we assemble them. And we use pick-and-place machines and robotics. So Wistron is here, Foxconn is here, Pegasus is here, Tata is getting into very big in EMS. Kaynes is we have 22 lines. And then in that you have the PCB fabrication, which we're still a little bit nascent, and we have a lot of growing up to do there. But on the EMS side, we are now the number 2 mobile manufacturer in the world. And now what that represents is an opportunity to go backwards within the value chain. That means that we are going to be a good buyer of the bare wafers, which we're importing today. We'll be able to do this in the contiguous Indian country within our borders sooner, and hand over those wafers within India. The packaging is another area between the wafer and the EMS, which is now emerging in India. Tata has expressed interest in doing OSAT, which is nothing but outsourced semiconductor assembly and test, and this is the area of ATMP, assembly, test, marking, and packing. So once the bare wafer comes from TSMC or Global Foundries or Intel or TI into the country, it has to be chopped up into small squares, put inside the package, and then it has to be put on the board. This is the packaging, and there's a whole area of test. Now, all of these require ecosystems, believe it. OSAT and packaging requires hundreds and hundreds of vendors. Fab requires hundreds, if not thousands of vendors. Chip design needs universities. It needs design services companies. So all of these ecosystems are now building. And the country has basically started with the back-end manufacturing, low value add, and we're progressively shifting left, adding more value, trying to do more and more downstream value addition and manufacturing. Ultimately, the dream would be to even do the individual components in India, which are all 100% imported today.